Hello, my dear students. Welcome back to Mathsful YouTube channel. Today we are going to solve some example from the topics of exponents, which is from grade 8 CBSE as well as the remain all other boards also. So let's see some examples, some word examples from the exercise 4.2. Let's see the example here. Everybody knows about the laws of exponents, right? So using those laws of exponents and different forms, different ways of expressing the given numbers in standard form as well as in expanded form. So that we already know. Now we are continuing the same with some word examples, right? So that is one example here in this exercise. The example number 7 here. We're done till example number 6. Today we will continue with the sum number 7. So what is the sum number 7 here? You can just see. Divide the number. The number is divide the number 13.31 into 10 raised to 10 by the number 1.21 into 10 raised to 15. This is the number given, right? And we need to write the answer in standard form and write the number we have or the answer we have in standard form. Answer in standard form. So that is the question number 7 here. So how to get it? First, we need to divide this 13.31 into 10 raised to 10 by 1.21 into 10 raised to 15. So what we need to do this, first we'll remove this decimal part, okay, and write it in the multiples of 10. So what we do here, this 13.31 into 10 raised to 10 can be simplified, or we can write this number in integer form by moving this decimal to the right side, 2 places to the right side, so that this decimal part will be removed and it will convert it to an integer part. So it will be 1331. So the decimal is moved to the right side, and when the decimal is moved to the right side, what should we do? We should multiply it by negative power of 10, right? When the decimal moving from left to right means to the right side, then we need to multiply it by 10 raised to negative power, and that negative power will be the number of digits. So how many number of digits we are moving to the right side? 2 digits. So it will be 10 raised to minus 2, and this 10 raised to 10 will remain as it is. Now you can rewrite it as 1331 into 10 raised to. So here again we need to use the laws of exponents, which are what it is, 10 raised to minus 2 into 10 raised to 10. So it is in the form of x raised to m into x raised to n. So the multiplication of two exponents with equal base, right? So what it would be? It is equal to m plus n, x to the power m plus n, right? So this will become, so it is minus 2 and your m is minus 2, n is 10, so 10 plus minus 2 means 10 minus 2. 10 minus 2 will be 8, right? So here we have converted this decimal number in integer form in this way, 1331 into 10 raised to 8. Also, the second number to be divided by which it is to be divided is 1.21 into 10 to the power 15. Again, we remove the decimal part from this number, and it can be written as 121 into 10 to the power again minus 2, because we are moving decimal to the right side, and is multiplied by 10 raised to 15 as it is. Again, we use the law of exponent, same law of exponent, x to the power m into x to the power n, which will be equal to 10 x to the power m plus n. Again, minus 2 plus 15 means 15 minus 2, which is equal to 13, right? So now first we divide this 1331 by 121. So can you check whether this 1331 is in multiple of 121? We can try to write the table of this 121. So it is 121 into 2, and if you see 121 into 10 will be how much? 121 into 10, 121 tens are, it will be 1210. But this number is more than 12, 1 0 means we need to divide it by 11, 12 or 13. We need to check. If I multiply this 121 by 11, how much it will be? So you can use the table of 11. 11 ones are 11, 1 carry. 11 twos are 22 plus 1, 23, 2 carry. 11 ones are 11 plus 2 is 13. So means it is 11 times 121. So here I divide this 1331 by this 11 so that I have a quotient as 11 again. No, we are dividing it by 121. So quotient will be 11. So this 1331, the remainder will left with 0, means we can say here 1331 into 10 to the power 8 divided by 121 into 10 to the power 13 will be equal to. So dividing this 1331 by 121 will be 11. So we have 11 into 10 to the power. Now here again we have exponents like this, x to the power m upon x to the power n. So using that law of exponent, whenever there is a quotient of two exponents with equal base, it will be simplified by taking the difference of their exponents. So it will be x to the power m minus n. But what is your m? M is 8 and n is 13. So it is 8 minus 13. So it will be equal to 11 into 10 to the power minus, how much is 8 minus 13? It will be minus 5. Okay, so I can write 1331 into 10 to the power 10 upon 121 into 10 to the power, not 10, it is 8 here. It is 8 and this is 13. 121 into 10 to the power 13. It can be expressed as, we got it as 11 into 10 to the power minus 5. Right? It was 11 into 10 to the power minus 5, which will be equal. Now we need to write it in standard form. What is the standard form? In standard form, this number should be less than 10. Here it is 11, so I should convert it in number less than 10 like this. It is 1.1. So what we have done here, we have put a decimal. Actually 11 is nothing but 11.0. So we have moved our decimal to the left side, means from right to left. So what should we do? We should multiply it by 10, right? And this 10 to the power minus 5 will remain same. As I already told you, whenever we move the decimal part to the right side, we need to multiply it by 10 to the power negative powers, and that power will depend on the number of digits we have moved from left to right or right to left, right? So here we have moved our decimal to the left one place, means it is 10 to the power 1, right? When we move from left to right, negative power. When we move the decimal from right to left, we need to multiply it by 10 to the power positive number. And that number depends on the number of places we moved the decimal. So here we have moved only one place. So it should be only 10 to the power 1 only. And it will be equal to 1.1 into 10 to the power, how much? Again use the law of index, law of exponents here 1. It is in the form of x to the power m into x to the power n, which will be x to the power m plus m. So how much it is? 1 minus 5. How much is 1 minus 5? It will be minus 4. So this is our required answer. I hope it is clear for everyone. Now let's move ahead. One more example. What is the next example we have? We have the sum number 8. What is the sum number 8? The sum number 8 is add 6.54 into 10 to the power 7 with 189.5 into 10 to the power 10 and write the number or write the answer in standard form. Again, it's very easy sum. We need to just add those numbers. Okay, so what it will be, the numbers given are 6.54 into 10 to the power into 10 to the power 7 with 189.5 into 10 to the power 10. Right? So this is the number here we are given. We need to add this number, and whatever the answer we will have, we need to write it in which form? In standard form, right? So how it can be written? Let's see. So what to do in this case? First, whenever asked to add such numbers in decimal form and they are multiplied by some powers of 10. So what to do in this case? In this case, we need to make the these parts, means the powers of 10 equal first. Either we can make this 10 in terms of 10 to the 10 raised to 7 in terms of 10 raised to 10, or convert this 10 raised to 10 in terms of 10 raised to 7. So what should I do here? I will make this 10 to the power 7 in terms of 10 to the power 10. So what it should be, to make this 10 to the power 7 to 10 to the power 10 means we need to add 3 to this. Means adding 3 to this means we need to move this decimal 3 places to the left side. But we have only one place here, that is 6. So what about the remaining 2 places? They will be 2 zeros there. Means we can write this 0.654 into 10 to the power 7 in terms of 10 to the power 10 as 0.00654 into 10 to the power 10, right? Plus, I will keep this 10 to the power 10 term as it is 189.5 into 10 to the power 10. So what will happen now? Now here the first number is 0.00654 into 10 to the power 10. And to the right side, the second number is 189.5 into 10 to the power 10. So I will keep 10 to the power 10 as it is, and we add this remaining part, the decimal part of these two numbers. Means 0.00654 is added to 189.5. So remaining digits are not there, so I can just put 0 there. We have here 5 places after decimal in the second number, so we need the same number of digits to the right side of this number also. Now we can add these two. We know how to add the decimal numbers. We add all the decimal part, that is numbers to the right side of the decimal as they are, just add them. So it's 0, 0, 0, everything is zeros. It will be like this. 6, 5, 4 remain as it is, this 1, 0 as it is, this 5 remain as it is, and 189, the integer part plus 0 will be 189 only, right? So it is equal to 189.50654 into 10 to the power 10, right? Now we need to write in a standard form. So this is our answer. The addition of these two numbers is 189.50654 into 10 to the power 10. Now we need to write it in standard form. So what is the standard form of this number? It will be 1 point. In standard form, your integer part must be less than 10. So whatever the digit, the first digit here we have, we place the decimal after one digit from left to right. Means we need to move this decimal part 2 places here like this. Means when we move the decimal to the left from right to left, what we need to do? We need to multiply it by 10 to the power, how much? Positive power, that is 2 places. So what will happen? It is 1.895064 into 10 to the power 2. And this 10 to the power 10 remain as it is. As we know, we need to multiply to the 10 to the power positive power when we move our decimal place from right to left. Means we need to multiply by 10 to the power positive 2 because we are moving decimal from right to left side. Okay, so it is 10 to the power 2. So our standard form now will become 1.8950654 into 10 to the power. Again, use the law of exponent. Which law of exponent we can apply? X to the power m into x to the power n equal to x to the power m plus n. So it will become 2 plus 10, which is equal to 12. So this will be our required answer for this sum. When we have added two numbers in exponent form in the powers of 10 and they don't have the number of digits equal, or the powers of 10 are not equal. So first we have made the powers of 10 equal, and then we have added the numbers, and then whatever the answer we have converted in standard form. So that is the answer for this example number 8. I hope it is clear for all. Now let's see the next sum. So see this number, students. Example number 9 is very easy. We are given that the special balances can weigh something as small as the number given is the weight for the object is 0. How many zeros are there? 1, 2, 3, 4, 5, 6, 7 zeros are there. 1, 2, 3, 4, 5, 6, 7, and then 1. This much grams. This is the weight of some object. So special balances can weigh something as small as 0.000701 grams. The question is to express this number in standard form. So we have seen how to convert the numbers in standard form. So this number which is in standard form, its integer part must be less than 1, right? So here if you observe, we have it is very much smaller, right? Integer part must be non-zero and it should be less than 1. It should lie between 0 to 10. It should be greater than 0 and less than 10, right? So means what we need to do here, we need to write it like this: 1.0 into 10 to the power. So how many 10 to the power here it should be? So as I told earlier, the power of 10 will depend on the number of digits that we have moved our decimal place. So decimal here. So how many number of places we have moved this decimal? It is 1, 2, 3, 4, 5, 6, 7, and 8. Right? We have moved our decimal place, decimal from left to right now. Means the power of 10 must be negative. And how much it will be? It will be equal to 8 here. So it is 1.0 into 10 to the power minus 8. So this will be the required standard form of the given number. So you can say that the special weight of an object which was 0.0000001 gram, it can be expressed in standard form by writing it in this way: 1.0 or simply 1 into 10 to the power minus 8. Why it is minus? Because we have moved our decimal from left to right and it is moved 8 places. So we have put negative 8 as a power of 10, right? So this will be the required answer for this example. I hope this sum is clear for all. You can see, students, the number is quite bigger one. The sugar factory, see the question given, a sugar factory has an annual sale of 3,720,000,000 kilograms of sugar. And we need to express this number in standard form. So for that, we must know this. What is a million? How much is 1 million in lakhs or crores? How much billion is in lakhs or crores? So here we can see that 1 million is nothing but simply 10 lakhs. So 1 million is nothing but 10 lakhs. You can see 10 lakhs means how many zeros are there? It will be 6 zeros after 1, right? Then we can write the 720 million in this way. 720, and again we can add 6 zeros with that 720. That gives us 720 millions, right? And then we must know how much is 1 billion. 1 billion is nothing but 100 crore. right? So that 100 crore means how much zeros will be there? After 100, we must put 7 zeros, right? Because 1 crore is nothing but 7 zeros there after 1. So here 100 crores, 1 billion nothing but 100 crores. So it will be equal to, after 1 we have 9 zeros, right? We can count the number of zeros: 1, 2, 3, 4, 5, 6, 7, 8, 9. That is nothing but 100 crore. So here it is 3 billions. So 3 billions is nothing but 300 crores. Means it will be like this. So we can write the number 3,720,000,000 kgs as in this way. You can see here it is 3,720,000,000 kgs. So here how much it is? 3,720 millions. So means it is 720 lakhs, right? So here you can see after 720 we have 6 zeros, right? 1, 2, 3, then 4, 5, 6. So this is a number we need to write. This 3,720,000,000 kg is equal to this much. You can check how many number of zeros are there. If you see in 720 million we have, after 72 we have 7 zeros. After 72 we have 1, 2, 3, 4, 5, 6, 7 zeros. That's right. Right. So this is a number. This is the number of kgs that sugar sells in a year in a sugar factory. So now we need to convert. Now it is easy to convert this in standard form, as the question asked is to express it in standard form, right? So here it can see that 3,720,000,000 kg can be expressed in the form of standard form. That is, as we know, in standard form we must have the integer less than 10 and greater than 0. So here is the first digit 3. So we put the decimal after 3 only, right? So it will be equal to 3 point. Write the non-zero digits first, and the remaining part, whatever the number of zeros we have, we express it in the power of 10. So as we know here, 3.72. So where is the decimal here in the 3,720,000,000? There is no decimal, means the decimal will be after this last zero here. Okay, it will be 3,720,000,000.0 kg like this. Okay, means our decimal, now we are moving this decimal to the left, right? From right to left we are moving it. And how many number of places we are moving? You can check: 1, then 2, then 3, 4, 5, 6, 7, 8, and then 9. So we are moving our decimal to the left, that is from right to left 9 places. Means we should multiply this number 3.72 by 10 to the power 9, right? So in this way we have our standard form of this numbers 3,720,000,000 kilograms as 3.72 or 3.72 into 10 to the power 9. So that will be our final answer. I hope it is clear for all, right? So you can try to solve this type of examples. Let's see one more. Okay, so see the sum number 11. The sum is given like this: the number of blood cells per cubic millimeter of a blood is approximately 5.5 millions. So in a 1 mm cube of blood there are 5.5 million red blood cells, right? So here, if the average body contains 5 liters of blood, the question is what is the total number of red cells in the body, and we need to express that number in standard form again. So as we know that 1 millimeter cube of blood has 5.5 millions of the red cells, right? Means again we need to express in the zeros. So 5.5 million, as we know million will have how many zeros? There are 6 zeros. So we have put 6 zeros after 5.5. Here you can see how many number of zeros we have. There are 6 zeros, right? Now, as it is, we know that 1 liter is nothing but 1 lakh millimeter cube. Right? This is the expression, or we can convert liter in terms of millimeter cube as in this way. As you are given that the red cells per millimeter cube, we have expressed this 1 liter in terms of millimeter cube. It is 1 lakh millimeter cube, right? So as we know, it is given in the example that a body has average of 5 liters of blood. So we need to convert, or we need to express that 5 liters again in terms of millimeter cube, as the blood cells given are in millimeter cube. Per millimeter cube it is given. So for 5 liters, we can express it as 5 lakh millimeters cube. Now, as it is given that in 5 liter blood, as a body has average of 5 liters of blood, we can have the number of red cells in this 5 liters of blood as this way. So 5 liters of blood is nothing but 5 lakh millimeter cube, and is multiplied by, since each millimeter cube has 5.5 millions of red cells, so we have expressed it, we have multiplied this 5 lakh millimeter cube by 5.5 millions. So 5 lakhs has 5 number of zeros, 5.5 million has 6 number of zeros. We have multiplied this in these parts, non-zero digits. Here we have 1 is 5 and here is 5.5. First I take the multiplication of 5.5 with 5. It comes as 275. 5 are 25, 2 carry 25 plus 2, 27. 2 is 27, 275. Since we have one decimal part here, 5.5, so you can put this is the digit decimal after 5, before 5. So it is 27.5. And again we need to put this number of zeros here. So how many number of zeros in all? There are 5 and 6. 5 plus 6, total 11 number of zeros we must have. Here after 27.5, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11. And then say so number we have expressed in the power of 10 as 27.5 to 10 to the power 11. And then this is our answer, that this much number of red cells will be there in a body. And then we convert in terms of the standard form of that number will be 2.75. As we know, in standard form our integer part must be greater than 0 and less than 10. So we can put the decimal after 2. So we are moving our decimal from right to left one place only. Means we have to multiply. Since we are moving it to the left side, we have to multiply by positive powers of 10. Since one place, we have to multiply it by 10 only. Means it will be 2.75 into 10 to the power 1, and this 10 to the power 11 remain as it is. So again using that law of exponent, it will become 10 to the power 12. So our answer will be this much, that 2.75 into 10 to the power 12, right? So these are some examples from this exercise. The word examples are given. We have to express them. We have to simplify and express them in the standard form of that number, right? So you can go through all these examples, practice these examples, and try to see how we can express the number or the answer we have it in standard form. So while writing standard form, we have to keep it in mind that our integer part must be positive, that is greater than 0 and less than 10 only. Means the digit in integer part must be 1 to 9 only. Okay. So in this way we have done these examples, and with this with these 4-5 examples, this exercise will over, and along with that this topic will also over. Practice this example. If you need doubt, you can ask me anytime. Thank you.